As you might expect, I have gotten a lot of emails the last few days about the case study assignment. They ask some similar questions, and so I thought I should make a video about some of them. I know a lot of groups that haven't contacted me or haven't contacted Jingya may be struggling with some of the same issues. So let's talk about some of the common questions that come up. One thing that a number of groups have asked about is the relationship between temperature and electricity demand. I know that the problem statement was a little bit vague about this, just directing you to a review of scientific literature and asking you to try and figure something out. This is actually a really common thing. Once you get out into the real world and you have to figure out how to model something that doesn't have a really easy solution to it, it's hard to balance accuracy with data availability. And so there are a lot of situations that you'll probably see in the future where you either have to decide on an approach and then try and look for data to support implementation of that approach, or you might have a data set that you know is available already and have to figure out what's the best approach to actually use this data. It's a bit of a chicken and egg situation where some groups will find a data set and want to know how to use it, whereas other groups will read the paper and think, oh, well, this really makes sense. Now I just need to find data that'll allow me to use it. And it's okay if all the groups have some slightly different solutions. But the basic idea is just that there's some comfort zone in which a particular household would have some kind of baseline use of electricity that wouldn't vary within a few degrees very much. But if it gets hotter or if it gets colder, then electricity demand for heating and cooling is going to go up. And you just need to find some paper to support the notion of exactly kind of how much is it going to increase per degree of temperature change outside of that comfort zone or baseline. You're not likely to find something that's specific to West Lafayette, Indiana, or Tucson, Arizona, or whatever your third location is. But the idea is that this relationship describing how electricity demand would change as a function of temperature is probably more transferable across locations than the temperature data itself. The temperature is going to change. The weather is going to be different in all these locations, and that's a given. But the relationship between how that temperature affects demand should be something that you can make an argument is relatively universal. The exception for that is if you find a study that is exploring that relationship, but it's doing it in a developing country or someplace that has very different construction techniques or very different access to electricity in the first place, then we might think maybe the relationship is going to be a little different. Another issue that I've gotten a lot of questions about is how exactly does the battery operate? The battery does not have to be fully charged before you use it. Basically, you can draw whatever energy from it that it currently has stored. So whenever demand for electricity exceeds solar production, the first priority is to use the battery. And then you would purchase energy from the grid if the battery is empty. Likewise, whenever the solar production exceeds demand, then the first priority is going to be to charge the battery. But if the battery is full, then you can sell energy back to the grid. Another issue related to the battery operations is one of the parameters listed in the technical specifications for the Tesla Powerwall, and that's the power rating. We're told that it has a 5 kilowatt power rating, which means that you can only draw 5 kilowatt hours of energy per hour. It's basically a restriction on how quickly you can discharge the battery and draw power from it. You should model that as meaning that you can only withdraw 5 kilowatt hours of energy per hour, but you don't have to consider that as having any limit on how quickly you can charge the battery. So you could put more than that into the battery in a given hour, but you can only withdraw 5 kilowatt hours per hour. In order to model all of these operations without having really complex statements in Excel, you probably want to break it out into smaller pieces. You want to have a different column for information like how much energy is demanded in a given hour, how much energy is currently in the battery at a given hour, how much gets charged, how much gets sold to the grid, how much gets purchased from the grid. Some of those you could combine by allowing the values to be positive or negative. In the case of selling or buying energy from the grid, you could think of a positive amount as being purchased from the grid, whereas a negative amount means that you're selling energy back. That would allow you to combine some of those columns into a single value, but you probably still want to kind of break things out so that you have basically a lot of different columns that tell you the status of different parts of the system on an hourly basis for that entire 20-year period. That relates to some of the difficulties that different groups have also mentioned related to file sizes and just managing the large amount of data that you have for this phase of the assignment compared to doing it with annual averages before. Some groups have mentioned some data limitations related to using Google Sheets or with using the online version of Excel, and have asked about whether we could just do the modeling with a single year of data. What I would recommend in response to that is a couple of different tricks to try and reduce the computational resources required to run things in Excel. On the one hand, you could try developing the model with Google Sheets or the online version of Excel with a single year of data, in which case you should end up with a bunch of formulas that could just be copied and pasted into another 19 years worth of data. So before submitting the assignment, you could kind of take the model offline for one person to take custodianship of it and add in the other 19 years of data and copy and paste your formulas and then update all of your analysis. That would be one approach, which would be fine. You could still attach the final version of it when you submit it in Blackboard. But there are some other kind of tricks that you can use for memory management that might also make things a little bit more amenable to working on it collaboratively. In some cases, you could create a formula, copy and paste it over the whole 20 years, and then once you get the results, you can copy the results and then just paste the values over it. So you're effectively overwriting the formula. That way, when you then have to use those intermediate results from one column as a formula in another column, you're not going to end up with a ton of different columns that all have formulas that refer back to each other. If you paste over the values, then it's just treating it like input data, but it doesn't have to refresh the calculations, and it's a little bit less prone to crash. If you do that, make sure that you explain what the formulas were that you used to calculate those values in the first place when you're writing up your report. That way, myself or Jingya can go back and understand where those numbers came from. Another idea for this would be for those of you that are putting each location in a different tab of your spreadsheet, you might think about splitting that out into 3 different files. So you would have a different spreadsheet entirely for each location. The modeling would be the same, so you want to work and make sure that you've got everything exactly the way you want it for West Lafayette. And then copy your file and replace all the data with Tucson, Arizona, or wherever your third location is. That could also reduce the size of the spreadsheet to something that's a little bit more manageable. Those are the 3 issues that seem to be coming up the most often when I get communications from groups. So hopefully this has been helpful, and I'm really looking forward to seeing what you've come up with later this week. Thanks.